Welcome back to my channel, where we love to simplify complex topics for you. Today, I'm going to show you how to implement the bridge design pattern in C#. Now, the bridge pattern is a structural design pattern that decouples an abstraction from its implementation so that the two can vary independently. The bridge pattern is especially useful to simplify inheritance structures, making them more flexible and adaptable. Let's consider the following class diagram. If you look at this class diagram, you'll see that it's quite simple, and it simply contains three classes with a superclass, car insurance, with two subclasses, comprehensive and third party, where comprehensive insurance basically means full coverage, and third party is when only the other driver is covered in the case of an accident. Now remember that the bridge pattern is especially useful to prevent the exponential growth of a class hierarchy. So let's say we want to introduce two discounts as a new feature. Let's say that we want to reward safe drivers and give them 10% discount. And the way that we could do that is to fit these vehicles with tracking units and in that way detect who are the safe drivers. And then let's say we also want to introduce another discount type for drivers with no claims, and we'll give them 15% discount. So if we go down the wrong track, we could do the following. We could say, let's just add another level in our class hierarchy and then inherit from the comprehensive and third party insurance classes and have a safe driver comprehensive, no claims comprehensive, and a safe driver third party and a no claims third party class that inherits from the specialized insurance types, including comprehensive and third party respectively. Now, you might still think this is okay. I don't think you are, but let's say that we want to go ahead and add yet another type of discount. Auto insurance as the type of discount, and we'll say that if you own your car, we'll give you 5% discount. So if we follow along this route, that means we'll have to add two additional classes, which takes our class tally from 3 in our first version of our class diagram. And then we went up to 7 classes because we added 4 additional classes, a safe driver for the comprehensive type insurance and one for third party, as well as a no claims comprehensive and no claims third party. So that took us up to 7 classes. And now we are adding another discount type, auto owners comprehensive, as yet another feature, and therefore we're adding 2 more classes. Now let's assume that you can still live with that. What if we add another specialized insurance type? Let's say we are adding an insurance type property damage that covers any damage to property that you might cause due to an accident, like walls or structures, etc. Now, if you do that, we need to add another 4 classes, as you can see there. And that takes us all the way from our initial 3 classes to 13 classes. So as you can see that it can easily get out of hand, not even to mention if you wanted to have specialized safe driver comprehensive type discounts, etc. As you can see, this is a very insufficient solution, and you will tell me that instead of using inheritance, we should use composition, and you are spot on there. Next, I'll show you how the bridge pattern uses composition to solve that problem. Now, the bridge pattern is particularly useful to prevent the exponential growth of a class hierarchy, or to allow you to refactor it once it has already gotten out of hand. So unfortunately, in our case, it has already gotten out of hand. So what the bridge pattern can help us to do is to effectively split our class hierarchy into 2 class hierarchies. So here you can see that we have a new class hierarchy where we have a discount abstraction with 3 concrete discount classes, including the safe driver discount, the no claims discount, and the auto owners discount. Now, you might ask what makes this better than the previous version, and the answer is simply we aren't duplicating any of these discount types for each and every car insurance type. Remember, we had a safe driver comprehensive, safe driver property damage, and safe driver third party classes, for example. As you can see here, instead of having 13 classes, we now have 8 classes. That's a reduction of 5 unnecessary classes. So what the bridge pattern effectively does, allows to bridge our car insurance types with the discount types. So here we have the official bridge pattern class diagram. Notice the important participants: a client, an abstraction, a refined abstraction, an implementer with its concrete implementers. Now, the implementer, as you can see, has an operational implementation that each of the concrete implementers override and implement. And then the abstraction has an operation that uses the implementer's operational implementation. Now, this might confuse you a bit, but let me show you how it applies to our use case. So as you can see here, we again have the client, and then here we've got our car insurance class as our abstraction. Now remember, the car insurance class had a get premium method, which is now made protected. That hash basically means it's a protected method, and then the plus is for a public method. Now we'll get back to the methods in a minute. So our car insurance class has 3 concrete insurance classes, or actually our refined abstractions, refined abstraction 1, 2, and 3, which is our comprehensive, property damage, and third party car insurance types respectively. And then we've got our implementer, which is our discount class or abstraction, with a get discount method that returns the discount as an integer. And then we've got safe driver discount, no claims discount, and auto owners discount as our concrete implementers. And here you'll see that we are now basically providing this calculate premium method that'll use the discount.getDiscount method to get the discount of the given discount type. And then it'll invoke the get premium method, that'll be an abstract method actually on the concrete or refined abstractions to actually get the correct premium, and then apply the percentage to the premium price. But if it doesn't make sense now, don't worry. I guarantee you it's going to make sense when we write the code. We're now going to implement the bridge pattern. You should recognize all of these classes from the insufficient class diagram that I showed you. This is actually the insufficient solution that I've implemented here. Now let's use the bridge pattern to refactor it and make it cleaner. So here you'll see that we have our car insurance class with 3 properties, including a year, a make, and a model of the car that we want to insure. And then it's got a get premium abstract method that you saw on the UML class diagram. Now it's got 3 concrete car insurance types, including the comprehensive car insurance. You'll see that we just hard coding an average of $165 here. Obviously, to calculate a premium, comprehensive car insurance premium, for example, is very complex. It's not simply returning a value, but it actually involves complex calculations. For example, the age of the driver, how old the driver's license is, where the vehicle is parked, if the driver is married or not, etc. Let's continue by looking at our other car insurance types. That includes third party. It is an average of $50. And then we've got our property damage car insurance type, which is an average of $60 in the United States. So now we've got our discount classes, and they are really the ones that bothers us, because let's, for example, look at this safe driver comprehensive class. So it extends comprehensive, which looks fine at first glance, but here you'll see that we've got this get premium method that basically gives you 10% discount for a safe driver comprehensive. But if you look at safe driver property, it also gives you 10%, but That's not the problem. The problem is we are actually duplicating the code, as you can see there. The same goes for the safe driver third-party class. So here we are actually violating the drive principle. And that is to further emphasize just how bad this solution is. If we look at the other discount types, for example, no claims, you'll see there's a no claims comprehensive, extending comprehensive, where we give a 15% discount. Again, this get premium method is actually duplicated, which is not recommended. The same goes for the auto owners comprehensive, where we give a 5%. Also for the property damage, auto owners property damage, again the 5%, but we're duplicating the code there, violating the drive principle in other words. So before we refactor this, let me just show you that this code actually works. So open up your terminal and run .NET run. And then here you'll see our output. So let me first explain. So here we are actually instantiating 3 car insurance classes: a safe driver comprehensive class, safe driver third party, and safe driver property damage for 3 different vehicles: a 2023 Mercedes-Benz E-Class, a 2023 VW Tiguan, as well as a 2023 Cadillac Escalade. So let's say that the Mercedes owner is only looking at comprehensive insurance and then comparing the different types of discount. For example, the safe driver discount with the no claims discount on a comprehensive cover, also the auto owner's comprehensive cover. For the VW owner, this owner is only interested in third party, again safe driver, no claims, and auto owners for third party. And then the Cadillac owner is only really interested in property damage cover. So this is for safe driver, no claims, and auto owners as well. And then you'll just see we're printing out something here. So this is basically just printing out these classes. We have a print method that basically uses string interpolation. So the car insurance class, the actual class's name, is basically converted to a sentence because that is in Pascal case. And then here we are saying the premium of the class, for example, the 2023 Cadillac Escalade, at the premium that actually gets returned. And then we round that premium off to 2 decimal spaces. Okay, so let's go ahead and run this again. I'm just going to clear the terminal and .NET run. As you can see, this solution is actually working, but it is highly inefficient. So let's go ahead and use the breach pattern to refactor it and make it cleaner. So let's start by creating our discount class that you saw on our class diagram. So remember, it's got a single method, and that's an abstract method. Therefore, we are also going to make this an abstract class. And then we'll say public abstract. It's going to return an integer and then call it get discount. Okay. Just going to remove the unused usings here. And then let's have a look at our class diagram again. Here you'll see that the discount class that we've just created is our implementer. So let's go ahead and add a comment here and mark it as our implementer. What we can also go ahead and do is get rid of all these insufficient discount classes. So I'm simply going to go ahead and delete all of them. Firstly, the auto owners comprehensive, property damage, and third party classes. Then also go ahead and delete the no claims discount classes, as well as the safe driver discount classes. Now, doesn't that feel nice? And our application looks much cleaner now, although we'll add a few more classes. One of the best things to do in software development is to get rid of code, and that's exactly what we're doing here now. So let's look at our class diagram again. So now, instead of having those 9 classes, we're going to have only 3. so that we don't duplicate any code. So let's go ahead and create our safe driver discount, no claims discount, and auto owners discount classes. Okay, so let's start by creating our first discount class, our safe driver discount class. So new class, safe driver discount. And as you have guessed, we need to extend the discount abstract class. Let's go ahead and implement the abstract method, our get discount method. And then we'll say that safe drivers are getting a discount of 10%. So we'll return 10 as an integer. Let's get rid of those unused usings. Then we can go ahead and copy everything because these classes will look similar. Then let's create our no claims discount class. And similarly, let's remove the unnecessary usings, but we're not duplicating code this time. We are actually giving 15% discount. Again, this no claims discount class in the real world will have a much more complex algorithm to actually determine the no claims discount. But to keep it simple and to make sure that you understand exactly how to implement the breach pattern, we'll hard code the 15% there. Now, let's go back to our safe driver discount class and just mark it as our concrete implementor 1, or A rather. Let's go back to our class diagram. So concrete implementer A is safe driver discount, B no claims, and then C the auto owners discount. Okay, so let's go ahead and also add a comment here to mark our no claims discount class as auto implementer B. Okay, so I'm going to go ahead and copy that again, and then we'll create our third and final discount class, which is our auto owners discount class. Okay, and then we are going to give auto owners a 5% discount. And this is going to be our concrete implementer C. We've now completed our implementer classes, the abstract one, our implementer, the discount class, and then all of our concrete implementers. Now we need to go ahead and modify our car insurance class, our abstraction. And like I said before, we are going to introduce a new method, a public method, calculate premium. And then we'll go ahead and make the get premium method protected. It used to be public. And then these methods will still override them. Our refined abstractions, in other words. Let's go to our car insurance class. So firstly, remember to change the get premium method to protected. Now it's going to give a few errors because the other methods are now still public. So let's go to comprehensive and then make it protected. Now remember, the protected access modifier in C# only allows subclasses to access a method on the superclass or parent class. Okay, and then for third party, and let's also update it for our property damage car insurance type. And then if we go back to our car insurance class, like I said, we are also going to introduce a new method. So it's going to be public. It'll return a decimal as well. And we said we are going to call it calculate premium. Now, if we go back to our class diagram, you'll see that this new method will invoke discount.getDiscount, and in this way get the specific discount, either safe driver, no claims, or auto owners discount. So what we need to do here is to add a private field for our implementer, and that is our discount class. So we can say private read only, because we're only going to assign it once in our constructor, and it'll be of type discount. Let's call it _discount, our global variable there. And then we'll also pass it into our constructor as a parameter. And then let's simply go ahead and do the assignment. Discount equals discount. So the first thing that we need to do in our calculate premiums method is to get our normal price. So we can say decimal, create a variable, call it normal price, and then we'll invoke get premium. Now, if you're not familiar with object-oriented programming, this might confuse you because here we are invoking the get premium method, which is actually an abstract method without a method body. But what makes this very powerful is that each of our concrete car insurance types actually override and implement this method. Okay, and next we are going to get the discount. So let's create a new variable, decimal. Let's call it discount portion. And then we'll say that is the normal price times the percentage. So first of all, we're getting back the discount as an integer, remember. So we'll use our implementer underscore discount and invoke the get discount method. And then we'll divide that by 100. And then to calculate the discount price, we'll simply return and say normal price minus discount portion. So this is all we have to do for our car insurance class. And remember from the class diagram that this is our abstraction. Okay, so now we have completed our abstraction as well as all of our implementers. So next, we've already gone and changed the get premium method's access modifier to protected. But remember, we are now passing in the discount as an argument to the constructor of our abstraction, our car insurance class. And we've got three classes, our refined abstractions that inherit or extend car insurance. So firstly, comprehensive. So here we'll also need to add discount as an argument to the constructor of comprehensive. And then go ahead and pass that through to the base. Okay, I'm just going to go ahead and copy that part because it will look similar for all of the concrete car insurance types. Third party. So there we go. And as well as the property damage car insurance type. Okay, so we have now successfully refactored all of the code except the client logic. If you go back to our program.cs class, you'll see that we have a few errors here, and that is expected. Now we've got only our comprehensive third party and property damage there. Let's go ahead and do the same for no claims. And then also let's do the same for auto owners. Okay, so we have another parameter or constructor argument that we need to pass to all of these classes. So firstly, if we are dealing with safe driver discounts here, we want to go ahead and instantiate a new safe driver discounts class. So we'll depend on abstractions. So say discount, call it discount equals new safe driver discount. Okay, and then we'll pass in the discount as our fourth constructor argument there. Let's just change that to safe discount specifically because we are going to have other types of discounts here too. So next is our no claims discounts. So let's say discount, call it no claims discount equals new no claims discount. And then we can go ahead and pass that in as our fourth parameter to the constructors there as well. And then our final type of discount is our auto insurance discount. So we can say discount, auto insurance discount equals new auto owners discount. I'm just going to change that to auto owners discount as well. Okay, and the auto owners is basically discount for people that own their own vehicles. In other words, they don't owe the bank any money. We have now refactored everything. We can see there's another error, and that is because our get premium method is now a protected method. And remember, I said that with protected methods, you cannot actually access it outside of the inheritance hierarchy. So instead, we need to invoke calculate premium from the client logic. And that's exactly what we need to do, because remember now, our discounts are no longer coupled to our car insurance types. We've bridged it over to its own class hierarchy, and therefore we need to invoke the calculate premium method, and that is to ensure that it actually uses our implementer to get the discount and to incorporate that into our price to return the discounted price. So let's go ahead and change this from get premium to calculate premium. And now if our refactoring efforts actually worked, we should still get the same result. So I'm going to keep those results up there. I'm not going to clear the terminal this time. So let's run .NET run. And then as you can see there, we still have $148.50 for our Mercedes-Benz on a comprehensive premium with a safe driver discount. The same goes for the third party and the property damage. And if we look at the no claims, again, you'll see that those values matches, and also the auto owners discount, those values are the same as well. So as you can see, the bridge pattern is particularly powerful to refactor code where there was an exponential growth in the class hierarchy. And remember, this time, if we are going to add another insurance type, we're only adding one class. And if we're adding another discount type, we're also just adding one class. And that's the power of the bridge pattern. If you enjoyed this video, please go ahead and like it and subscribe to our channel. Till next time.